In this dependent motion analysis example, we have a person who's trying to lift a block by walking backwards at a constant velocity of 5 feet per second in the x direction. The block is moving straight up in the y direction towards the pulley, which is up at the top. The pulley is 10 feet above where the person is pulling the rope from. We want to know what the velocity of the block is when his position x is 6 feet away from where he started, right below the pulley. Well, just like we did with the multiple pulley problem, we have to write an equation for the length of the rope. In this case, we've got two portions to this rope that we need to consider, the length of this piece and the length of this piece. When we look at the overall length, the first portion we get using the Pythagorean theorem, the square root of x squared plus 10 squared. Then we have to add on to that our portion, which is y. We're trying to find out what the velocity is when x equals 6 feet, and so we can solve this equation for y and say that y is equal to L minus the square root of x squared plus 10 squared. If we take the first derivative of that with respect to time, then I get for this portion dy dt, which is simply equal to the velocity in the y direction. L is constant, so the derivative of a constant is 0. And then I've got this portion here that I need to take the derivative of, and I'll have to use the chain rule to be able to do this. So I'm going to rewrite this up here as L minus x squared plus 10 squared to the 1/2 power, so that we can see what's happening when we take this derivative. Again, L is 0 as a derivative, but this portion right here will have negative 1/2 if we're taking the derivative of the outer portion, x squared plus 10 squared to the minus 1/2. Then we have to take the derivative of the inner portion, which is 2x, and then the derivative of x with respect to time, which will give us the velocity in the x direction. Our 2's will cancel, and simplifying, we'll get that the velocity in the y direction is negative x times the velocity in the x direction divided by the square root of x squared plus 10 squared. We're trying to find the velocity when x is equal to 6 feet, and we know the velocity in the x direction is 5 feet per second. So, plugging in those values, we get minus 6 feet times 5 feet per second divided by the square root of 6 squared plus 10 squared, and that will give us a value of negative 2.57 per second. The negative sign tells us that we're moving towards that pulley. If our x direction is moving away from the pulley, then our y direction must be moving towards the pulley. So we get 2.57 feet per second upward, which is our velocity in the y direction. We could continue this at this point and figure out what the acceleration is in the y direction as well. If we take our function of the velocity in the y direction, we take the derivative of that again with respect to time, then we can get what the acceleration is. Derivative of the velocity of y is equal to the acceleration in the y direction. Now to do this, we're going to have to use the quotient rule, which is the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. So the bottom is the square root of x squared plus 10 squared times the derivative of the top, which is this piece right here. We've got product rule happening there as well in order to do this. So we take the derivative of this. Product rule is derivative of the first times the second plus the derivative of the second times the first. So derivative of the first is minus 1 times the velocity in the x direction. So we end up with negative velocity in the x direction squared. That would be the derivative of the first times the second plus the derivative of the second times the first. So there's the first. The derivative of the second will give me the acceleration in the x direction. So there's my bottom times the derivative of the top minus the top, which we're going to call positive because we have this sign here, the top, x vx, times the derivative of the bottom, which will be 1/2 using chain rule, x squared plus 10 squared to the minus 1/2 times 2x vx, all divided by the bottom squared, which will give me x squared plus 10 squared. My 2's cancel here. I also know that I'm going at a constant velocity in the x direction, so this term right here goes to 0 and will drop out. So if I simplify this, I'll get that my acceleration in the y direction should be equal to the velocity in the x direction squared times 10 squared divided by x squared plus 10 squared to the 3/2 power. And I'll let you go through and check that and see how I ended up with that. Then plugging in what we know, velocity in the x direction is 5, so 5 squared times 10 squared divided by 5 squared plus 10 squared to the 3/2 power gives us an acceleration of 1.79 per second squared in the y direction. The acceleration of y was not asked for in the given statement, but I decided to go ahead and go through this process and solve for it so that you could see what the process is to find acceleration, that it's very similar to solving for velocity, and we can use dependent motion analysis to solve for that as well.